this time we'll be discussing some examples for our free vibration response of a single degree of freedom system. So last time na ito ang example is we have the mass and the spring model. We have the mass spring model, and later on we have already discussed the mass spring and damping model. Now this time we try to relate the equation of motion that we solved last time for our single degree of freedom system na kuan, free vibration response. So again, now to recall, a free vibration response is a system no nga ga-oscillate the system or the structural system is oscillating. There is an oscillation, there is a vibration, but the dynamic force is set to zero. So mo to siya nga we have the general equation of motion, u double dot plus the damping coefficient u dot plus the stiffness times the lateral displacement is equal to P of t. In a free vibration response, this is being set to zero. That's why we have ang equation, the general equation of motion became the mass times the response acceleration u double dot plus the damping coefficient times the response velocity u dot plus k times the lateral displacement u is equal to 0. Now, in a free vibration response, again, natay duha ka kuan, natay duha ka case. The first one, we have the undamped condition. No? Damping is equal to 0. So we know that the undamped condition where C is equal to 0, in real life, this is not really this is not really existent. No? Di siya ingon nga exist. We also have another one, we have the damped system. So in the damped system, naatay tulo ka kuan, nagyapon tay tulo ka cases. The first one, we have the underdamped system. You have the critical damped system. And then we have the overdamped system. So, review lang gamay no, a underdamped system, mo ni siya ang when the damping coefficient is less than the 2m omega. Again, the 2m omega, this is our critical damping C sub C. Critical damp system mo ni siya when the damping coefficient is equal to our critical damping 2 times the mass times the natural angular frequency. And then the overdamp, this happens when the damping coefficient is greater than the critical damping. Now, in real life, this is the more realistic example in real life structures. No, they are underdamped. Then the overdamp is that is non-existent and then gusto na siya makita. So let's start with our basic recall. Let's just recall the equation of motion sa ang undamped free vibration system. So last time no taas kay tag process no in trying to find the equation of motion for each type of free vibration system. So nata equation of motion for the undamped, we naput the equation of motion for the underdamped, for the critical, and for the overdamped. And then task ka itong process na and then task ka, dagan kay variables nga ang remember. For example, for the undamped free vibration system, no, if you remember, our equation of motion for the lateral displacement u of t is equal to initial displacement times cosine of the natural angular frequency omega times the time plus the initial velocity v naught or vo omega sine omega t. And then our u dot t or our velocity v of t is equal to negative u naught omega sine omega t plus v naught cosine omega t. So kani siya no, the velocity is just the derivative of our position. So mo to siya again no u dot kani usa ka dot pasabot this is the first derivative of u lateral displacement. So kani okay pa ni siya. Dali rin siya dumdumon ang kuan. We have the v naught over the omega. So the v naught this one is the initial velocity, this one u naught is the initial displacement. So ato natagal na natong simplified version no para mas dali na to madumduman for an undamped free vibration system no. Ato na lang na siyang ano, padalion na to atong life aron mas dali na to siya i-solve. Let's say we have our u is equal to alpha cosine omega t plus beta sine omega t, and then our velocity v is just equal to negative alpha omega sine omega t plus uh, the beta omega cosine omega t. So ganin na lang ito memorize. So instead of using the u naught and then the v naught omega, you can use this equation. Atong arbitrary constants are just the alpha and then the beta. Now, to solve the alpha and the beta, mo na din itong initial conditions that time is equal to 0. The lateral displacement is the initial displacement. And then the velocity is the initial velocity nga v naught. Then eventually mo come back na mag-ibot nga equation. But for the problem solving, mas dali siya if ngani na lang ato ang memorization. Next, for the underdamped free vibration system. Again, no, si undamped, the undamped is there is no damping. Moto siya ang damping coefficient is equal to 0. Now, in the underdamped free vibration system, our damping coefficient is not equal to 0. We have a value for our damping coefficient. But in the damping coefficient, in the underdamped free vibration system, our damping coefficient is less than the critical damping, or C is less than 2m omega, or the 2 times the mass times the natural angular frequency. Now, if you remember the equation of motion for the underdamped system, u of t is equal to e to the negative psi omega t. So, recall lang nato no, si psi, this is what we call the damping ratio. That is the ratio of your damping coefficient over the critical damping. So, if you recall the equation of motion for this one, we have the e to the negative damping ratio, negative psi omega t, times u naught cosine omega, the damping omega dt, plus u naught plus, sorry, this is not u naught, this is u naught plus the v naught times the psi omega over the damping angular or damp angular natural frequency sine omega dt. And then our velocity, v of t, so mo to siya no, medyo taas-taas di siya. So we have the e to the negative omega psi omega t times etc. etc. So taas kahit na siya, imo pa ni a, differentiate kani sila nga terms. Now, para madali gyapon na tong life, kani lang gyapon na to ang dumdumon, no? We can just use this equation. U is equal to e to the negative psi omega t. So just remember this one, no, para dali naman sa na e to the negative psi omega t naman na, and then times what? Alpha cosine omega dt plus beta sine omega dt. And then for our velocity, differentiate lang yapon ni siya, that becomes e to the negative psi omega t times negative alpha omega d sine omega dt plus b omega d cosine omega dt minus psi omega e to the negative omega t times alpha cosine omega dt plus b sine omega dt. So, actually, mas dali ni siya memorize no kasi gani because alpha, beta lang. Kanino dyan din i-memorize? Ang first one. And then, i-differentiate na ninyo. So, kanino, this is just the derivative of this one. Nga, nganong u na lang man akong gigamit og v, nganong dili naman u of t or v of t. So, kung lang gina siya no, u of t is to emphasize that the u or the lateral displacement nga u is a function of time. Pasabot, the u changes through time. Same also with the velocity, it also changes through time. So, same lang po nga condition, mo dito nga time is equal to 0, then kay u is equal to this value and our v is equal to this value. And eventually, masolve ninyo si alpha o si beta. So don't worry, later on we will have our example for that one. And then for our critically damped free vibration system, so muna siya no when the damping coefficient is equal to the critical damping, which is equal to 2m omega. No? So in this one, if you remember, the characteristic equation, diba, we have the S is equal to, we have the C, negative C over 2m plus or minus the square root of C over 2m squared minus K over M, diba? In a critically damped free vibration system, this part here is equal to 0. So we are left with S is equal to negative C over 2m or simply negative omega. So we have only one solution. Therefore, the general equation for this one or solution is, as you recall, moto siya si u of t is equal to e to the negative omega t times, we have the u naught plus, we have the u naught, let me just delete this here, plus v o omega t, no? And then you differentiate this one, you will arrive that the velocity is equal to e to the negative omega t times beta plus minus omega e to the negative omega t times alpha plus, sorry, not beta, but ato lang i-differentiate si u of t, that is times u naught plus v o omega minus omega e to the negative omega t times u naught plus u naught plus v o omega times t, like this one. Now, para mas simplified na gyapon na to ang pagdumdum ani, we just let u is equal to e to the negative omega t. So don't forget yun aning values na din nila, no? Times alpha plus beta times t. And then our velocity will become e to the negative omega t times beta plus, sorry, not plus but rather minus, because the derivative of the exponential, that is minus omega e to the negative omega t times alpha plus bt. Or our velocity is just equal to, we have the e to the negative omega t, we just factor them out, and we have b minus alpha plus bt, or since this expression alpha plus b times t just equals to the u or b minus the displacement u. So dali na lang gid siya dumdumon. So same lagi po din no, mo lang din to, lalagyan po the initial condition at time is equal to 0, u is this value, and then your v is this value. So later on, ato gina siya nga tawag example para mas masabtan. And lastly, for the overdamped free vibration system, now this is when the C is greater than the critical damping or the damping coefficient is greater than 2m omega. So if you recall now the characteristic equation, we have the ms squared plus the cs rather. We have the cs plus k is equal to 0. And then we have our s is equal to negative c over 2m plus or minus the square root of c over 2m squared minus k over m. So this is similar siya sa kung ano sa solution with the underdamped system. But since see the determinants here is greater than 0, so we don't have an imaginary solution. So we just have our solution equal negative of the psi omega plus or minus omega square root of psi minus 1. So basi nakalimot mo no, basi nakalimot mo nga CS, di ba? If you remember that the general solution, we have the u of t is equal to g1 e to the s1t plus g2 to the s2t. So mo man siya to ang gina substitute diri sa s2. So our general solution for the overdamped free vibration response system, so katong dali na lang gid kay nga kuan memorization, we have the u is equal to alpha e to the omega t is square root of plus, sorry, there is no plus. No, omega, that is just omega t times the square root of, we have the plus, because of this term, no, we have the plus omega square root of psi minus 1 plus beta e to the, we forgot the psi, negative psi, e to the negative psi omega t minus omega square root of epsilon minus 1. Now again, no, by the laws of the exponent, pwede na ito ni mapagawas these terms because mura man ni siya same ra ani nga concept no, that e to the a times e to the b is equal to e to the a plus b. So ato lang siya gipaatras para ma-factor out nato siya. So we just factor out this one. We will have e to the negative psi omega t times alpha e to the, we have omega t there, omega t square root of psi minus 1, omega t also there, plus beta e to the negative omega t square root of psi minus 1. So kanila yung dumdumon. And then you differentiate this one, and then you will arrive with the velocity.